double bonds are more reactive than single bonds, okay? And triple bonds are more reactive than double bonds, which are more reactive than single bonds. You kind of think of it like this. Remember when we were outside doing our analogy and you were holding hands representing your bond? To build a double bond, you would have to hold two hands with somebody. So if you really like this person and you really think this is a stable bond, you're willing to let go of one hand to react, but not really the other one. Okay? So single bonds are very hard to break. However, that extra bond is quite easily able to let go and react with something. Does that make sense? So do you remember when we had to have light over top of our arrow for our substitution reaction? Yeah. And I said to you, when you first put them together, nothing happens. Then you can leave it on the windowsill for a while and you'll see a reaction. Remember that? You're going to do that tomorrow. When you take your alkene, something happens right away because alkenes are more reactive. And so that double bond is willing to let go and grab something else. And the breaking of bonds and the forming of new bonds is what a reaction is. That is the definition of a chemical reaction. Okay? So, if you haven't jotted that down already somewhere on there, you should. Triple bonds are more reactive than double bonds, which are more reactive than single bonds. And so therefore...
So that means single bonds are strongest then?
Yes. And so therefore, alkynes are more reactive than alkenes, which are more reactive than alkanes. Now you remember those physical properties? Back to the first bit of this sheet. Boys. Back to the first bit of this sheet. Physically, alkenes share roughly the same properties of alkanes. So I thought it was a bit redundant to write again. As you increase the number of carbons, the boiling point increases. As you increase the number of carbons, the viscosity increases. Just the exact same as it was on the last sheet for alkanes. Okay? So, but the chemical properties are, some of them are different, or slightly different anyway. Okay? So, the first one is combustion. And you can see an alkene combusting is still reacting with oxygen, and I still get carbon dioxide and water vapor. No problems, right? Exactly the same thing, nothing to really think about there. So, number 2 is oxidation. Well, this ties in with our last unit, oxidation reduction. And if I told you we were going to oxidize an alkene with I won't use bromine. We'll use KMNO4, acidify. Are you done building? You done building? Yeah? Okay, so you can just put the box aside and listen. Craig? Thank you. So, you could write that half reaction. You could look it up in your data book and write it down. And if I told you the alkene is making whatever, I would have to tell you what the product was. You could then write that half reaction by oxidation numbers, and then it must have gained so many electrons, and then it must have, everybody okay with that? So, but what you should kind of memorize for this new unit is that these things are easily oxidized, meaning they are going to lose electrons, meaning their oxidation number will go up. Okay? Okay? Devin and Leaf, you don't need to have a pen in your hand and be engaged with the sheet in front of you.
You just heard a couple of things there.
Yeah, and you should be as well, because it's better than daydreaming.
That's
So
not the last
do
night.
you want to argue with me, or do you want to just pick up your pen and start annotating?
Just saying afterwards.
I'm just saying. Thank you. Okay, so the diagnostic test, what does diagnostic mean?
Shows you what reaction happened.
Yeah, do you remember we saw that word a long time ago? Remember I used it over and over and over again for what are the diagnostic tests of this reaction? And there were things that we could see in a lab. So a stereotypical question of 2 unknowns, one being an alkane, one being an alkene. You could oxidize it and you would see your double bond being reduced, or oxidized, pardon me, but you wouldn't see a single bond. Okay, so we're going to do this in the lab tomorrow, and you're going to, that paragraph will come to life then, when you start to see it. Okay, so the next one, addition. So this is why you've got your molecules ready to go. Oh. Okay. Addition. This is comparable to substitution. So alkanes substituted, alkenes and alkynes do addition. Okay? Write that down. Good. Alkanes substitute and alkenes and alkynes undergo addition. So what happens is you break the double bond, then you attach the molecules to that double bond, and it's like a power play situation where you can just chuck more people on the ice. I don't have to undergo a substitution. I don't have to pull one person off and put one person on. I can just put extra people on. Okay? So, take your alkene that you have, and take your chlorine or bromine that you've made. And the first thing you're going to do with your alkene is you are going to break its bond. So go ahead, break it, one of its double bonds. You got it? Yep. And at the same, so it should look like this. And at the same time, take your Cl2 and break it apart, or your Br2. Got it? So you've broken this double bond, meaning your carbons at the moment only have 3 bonds to them. Is that true? So they are unsatisfied for like a less than even a nanosecond. And your chlorines, which you have broken up, can then attach into those spots. So go ahead and build your product. You see that? Have you added things to that molecule? Guess why it's called addition. Did you substitute anything for anything? No. How many products did you get from those 2 things that you just used? 1 product. How many products did you get with your substitution? 2 products. Okay, right. So what is that called?
Addition.
Addition. What would you name that compound? Close? Closer? 1, 2, propane on this board, yes, and you probably have ethane, yes? Yes.
Since it's just got the 2, like 1, 2, you don't have to put 1, 2 because
Could you have 1, 1?
No.
Could a 1, 1 exist, I mean?
yes.
Yes, so therefore you have to give the numbers. Okay? Now, when you made your addition, would it have been possible to have made 1, 1 dichloro?
No, because of where double bond.
Right. No, because when that double bond broke, each carbon was missing 1 bond, not 1 carbon was missing 2. You see that?
It's basically like taking the double bond and like putting those sticks and just like.
Right. So I'll say that again. In addition, it would be impossible to form 1, 1 dichloro as a product. Did you get that?
Because it wouldn't be able to keep up.
Because when I break that double bond, this carbon's missing something, 1 thing. This carbon's missing 1 thing. But there's not a carbon missing 2 things, so I wouldn't be able to add it to 2. Okay? So you end up putting a carbon on neighboring, or pardon me, a chlorine on neighboring carbons. Everybody get that?
Always be on neighboring carbon.
Always on neighboring carbons. The carbons that had the double bond now have a chlorine attached to them, one each. I was going to say something else about this, but I can't remember off the top of my head right now. Okay, so do it again, but this time you're going to take your alkene and you're going to add, the next page says water onto it. Raj, if you can't hold on to your balls, I'm going to take them away from you. Okay, so you broke this double bond, and then to the neighboring carbons, you added a hydrogen and an OH. You can see if you've got a chain of carbons, the OH might be in the middle or it might be at the end. Doesn't really matter as long as your H and your OH are neighboring carbons. What type of reaction is that called? What is the type of reaction that that's called? Addition. Okay? Now, this type of addition, we've added water to it, right? What do you call it when you add water to something? Hydrolysis.
Yeah.
So sometimes that's called hydrolysis, which is still addition, but it's a special kind of addition with hydrolysis. Everybody okay with that? You don't want to write that down?
So if it's like hydrolysis, you know that they're adding water, but other than that, they will tell you.
Right, so what's this one going to be called? Devin, you might not remember in 3 months from now when you're trying to study for your exam. Or 2 months, whatever it is. Your diploma. Okay, going back up there. What do you think that one might be called? So it's obviously not hydrolysis, because I'm not adding water.
Chlorophyll.
Okay. Good guess. Chlorification. Is probably closer.
Chlorination.
Except for, hold on. Raj and Co. This reaction would be the same thing if it was a chlorine, bromine, or iodine, or anything in group 7, which are called, what's group 7 called? Halogens. And so this is called, that's right, halogenation. Okay. So they're both additions, only one is hydrolysis. Craig, you need to write that down. Raj, you need to write that down. Halogenation, hydrolysis.
So all of the
All of the halogens would be halogenation. Yeah. Okay? So they're both additions, they're just a special, like a specific name for a specific type of
So
addition.
it could give you a question that says halogenation, and then you pick whatever you want.
or they wouldn't give you a question.
No, they wouldn't give you a question like that, like you're putting it on a diploma.
Well, no, because obviously it's multiple choice. So we can't really.
Right, so multiple choice would be, here's a reaction. What's the type of reaction?
Okay.
It is substitution, it is halogenation, it is combustion, or it is oxidation.
Would they give
Okay.
you one that had like addition and halogenation?
Would they give you one that has addition and halogenation?
Like in the.
That's actually wrong, it's probably oxidation as well, by the way, so take that question back, but anyway. Sorry?
Like if they gave you like what is the following reaction, they said like hydrolysis, addition, and halogenation.
Yeah, they could do that.
Which would you
No, they wouldn't give you addition and halogenation. They would give you hydrolysis, halogenation, combustion, and hydrogenation. Ah, hydrogenation.
Adding hydrogen.
What's hydrogenation going to be? Adding hydrogen. No? What?
You have to alkene. Is that what you're doing?
Okay, so